having multiple paths means that we might get into a situation where we have to control how we utilize those paths. One possible challenge is suboptimal routing. Another, how do we load share now that we have multiple paths? Maybe we want some of our traffic to go one way based on source or the application itself. That would be based on something other than destination-based forwarding. And occasionally, just because an available path is there, well, having that available path there doesn't necessarily mean we will use it. This is where policy-based routing really shines. Policy-based routing overrides the default operation of any routing device. All routing devices base forwarding decisions based on the destination. Where do you want to go? I'm going to forward based on that. That's what the routing table has. The routing table isn't a collection of both sources and destinations. It's just destinations. So policy-based routing says I can say where you came from, or maybe quality of service. It's really anything that we can match based on within something like an access control list or the length of the packet. That allows us to identify traffic, which would be interesting, and then override the default behavior of the routing table based on whatever we choose. And really our then condition, we have an if condition, which is like the match. Our then condition says, here is the next hop IP address. Here's the next device. So what I could do is I could say, this workstation's traffic is going to go through ISP1. The web server traffic, and maybe all other web servers, are going to go through ISP2. Even though they're just going out to the internet, maybe we don't even know the destinations and we're just default routing. We have the ability to choose which ISP now based on internal criteria other than just the destination. A lot of times when we implement policy-based routing, we're doing it based on routing based on the source. And we can know a lot based on the source. We can know, oh, you're from that subnet. And I know that that subnet is a collection of servers, and maybe even the type of servers. Or I know that you are from a subnet that's where the IP phones live. You could route differently based on source. You could also route differently based on things like quality of service. And you can even set quality of service parameters because we're going to use route maps. And we have the ability to set not just the next hop IP address, but things like the IP precedence or DSCP values, which are stored inside of the type of service byte. One last thing we can do, and last thing in terms of what we see on the page, is that we can perform load sharing. We could distribute traffic based on maybe something like, I've got two different ISPs, and I want to use both ISPs. So what I could do is I could say half of my networks are going to use ISP1, and the other half are going to use ISP2. Now you may want more control, and you have at your fingertips the ability to control that more. Maybe you only want a few networks to go through ISP1. All you have to do is craft the perfect route map, and you get to override what your router would do based on the routing table.